All right, we're up to 100 rubber bands and you can already see the forces coming into play. Basically, this whole science experiment is about how lots of little forces can create one big force. So what are these forces? Well, we've got the force of the rubber band, and it's a compressive force. It's squeezing in on the watermelon. And the force that's resisting that at the moment is the watermelon. The watermelon has got two kind of forces going on there. We've got something called a hydrostatic force. A watermelon is full of water, no surprises there. In fact, most of it is water, and it's got a rind on the outside. Now, hydrostatic basically refers to the fact that water doesn't compress. So this water balloon here is actually very similar to a watermelon, except when I compress it, well, it just squeezes out the other sides because it's got a rubber outside instead of a hard rind outside. So the water doesn't compress, it just shifts different places. Now with the watermelon, of course, the water can't really shift around. It's just trying to get compressed and it doesn't like to get compressed. So the forces at the moment are balanced, or almost balanced. The squeezing in is being resisted by the structural integrity of the rind and the water on the inside. Eventually, of course, the irresistible force of the watermelon will move the unmovable object of the watermelon, and it will go into the middle and all together, and at the same time, the watermelon will sort of explode or implode and then come out. So these are the forces at play. Now, exactly how much force is there? Well, I don't know, but we can use this little handy, it's actually used to measure fish and how heavy they are. But if I pull on it about the same width as that, it's telling me about 3 kilograms of force, or 3 kilograms of weight, I guess. And in terms of force, that would be 30 newtons. Force is measured in newtons. So that's the amount of force that this rubber band is exerting on the watermelon. So if one rubber band puts the equivalent of 3 kilograms or 30 newtons on there, we're up to 100. So currently there's about 300 kilograms of pressure squeezing in on that watermelon. And at the moment, it's holding out. For how much longer, I don't know. Sometimes you get a little bit of warning, the watermelon will start to creak or groan, or bits of juice will come out. Sometimes you don't get a lot of warning, it just goes, which is why it's important to stay away from this region and just to keep putting on the rubber bands, which is exactly what we're going to do. All right, so that's 100. We'll see how we go.